Hi guys, so today we're going to take a look at question 5 of the 2015 exam, paper 2. Alright, so we want to prove that tan A plus B equals tan A plus tan B over 1 minus tan A tan B. Alright, so first of all, let's write out the expression to prove. Tan A plus B equals tan A plus tan B all over 1 minus tan A tan B. Okay, so with these kind of questions, it's best to go from left to right. So we're going to try to manipulate the left-hand side, the tan A plus B, and end up with the right-hand side. But we're just going to try and go step by step. If we have a formula for something, just use it, even if we're not sure that that will lead to the answer. Alright, so let's start off with, well, we know that tan, let's say tan theta, is sine theta over cosine theta. Alright, so well, A plus B is an angle, so we can just use this formula. So tan A plus B equals sine A plus B over cosine A plus B. Okay, so, well, what the hell is sine A plus B? Well, we have a formula for sine A plus B and for cosine A plus B. So let's just write those down. Sine A plus B equals sine A cosine B, sine A cosine B, plus cosine A sine B, plus cosine A sine B. Alright, and we know that cosine A plus B, remember, especially in paper 2, the log tables is your best friend, and it's probably going to give you, if you literally just take formulas from the log tables, you're probably going to get 20% right off the bat, or more. Cosine A cosine B minus sine A sine B. Alright, so tan A plus B is sine A plus B over cosine A plus B. So sine A plus B over cosine A plus B equals sine A cosine B plus cosine A sine B all over cosine A cosine B minus sine A sine B. Now it's really not so obvious what to do now. All the kind of simple kind of formulaic steps are gone, but the important thing is we've done those simple formulaic steps. We've probably got half marks, maybe more than half marks, because the last couple marks, it is tough to go from what we have to the answer. But if you just think, I need to get to the answer at the start of the question, and you're like, I really just don't know how to do this, and you might move forward instead of getting these easy marks of just using your formulas. So this is kind of the tricky part. Alright, so we want to go from what we have to what we have in the formula, and it looks somewhat similar. There's 4 terms. There's two terms on the top, two terms on the bottom. There's a term plus term, term minus term. So how would we get what's on the top? Well, if we want to get a 1, that's kind of the weirdest one. It's not even a trigonometric formula. If we want to get a 1 in that position, well, we would divide cosine A cosine B by itself. So let's try that. But if we divide that by itself, we have to divide everything by it. So let's just divide everything by cosine A cosine B. Well, if we divide the bottom, so cosine A cosine B over cosine A cosine B, and then we have to divide this to make sure that everything is still equal. Sine A sine B over cosine A cosine B. And then all this is over sine A cosine B. Let's just put this in brackets. Sine A cosine B over cosine A cosine B. Plus cosine A sine B over cosine A cosine B. Alright, well, let's see if there's anything we can cancel. Well, immediately we can rewrite this term as 1, because it's something divided by itself. So let's put a 1 there. What about here? Alright, well, we have sine A sine B over cosine A cosine B. Well, if we put the sine A and the cosine A, if we kind of split that up into two terms, so like if we split that up into like a sine A cosine A by sine B cosine B, it becomes a little bit more obvious what to do here. But we know that sine A cosine A is just tan A, and sine B cosine B is just tan B. So we can just write this as tan A by tan B. So tan A tan B. And you do have, because we know what we're trying to get, that's kind of a pointer. So if you know that you want this kind of purple highlighted thing to be tan A tan B, you can actually kind of see it. If you didn't know what you wanted to be, it'd be harder to spot, but it being there helps. Alright, okay, so now let's take a look at this term, sine A cosine B over cosine A cosine B. Well, there's a cosine B in both things, so that can cancel to just be 1, and then we get sine A cosine over cosine A, which, as we know, is just tan A. And then if we finally look at this term here, cosine A sine B over cosine A cosine B, well, now this time the cosine A will cancel, and we get sine B over cosine B, and that is just tan B. And then we have what we were looking for. It's a little bit tricky. The tricky part is dividing everything by cosine A cosine B, but if you just think, well, we want this whole expression to equal what we're looking for, then it becomes a little bit easier to see what to do. But the main point here is, even if you don't get that, even if you can't figure that out on the spot, make sure to get those easy points. Now on to part B. Find all the values of x for which sine 3x equals root 3 over 2 for x between 0 and 360 in degrees. Alright, so what is the question giving us? Okay, so we have an equation that we want to solve for x. Sine 3x equals square root 3 over 2 for x between 0 and 360. Okay, well, we know how to solve an equation of the form like this. Sine theta equals square root 3 over 2. We just use the inverse sign. So let's just let theta equal 3x, okay? And then we're solving for theta between 0 and 360 by 3, which is 1080. Okay, so, well, when does sine theta equal square root 3 over 2? Well, it equals for, so sine theta equals 3 over 2, or more precisely, the magnitude for for something between 0 and 90, so in this case it's 60, sine 60 is square root 3 over 2. So for 60, 180 minus 60, 180 plus 60, and then 360 minus 60. So in the quadrant, so if we look at the unit circle, if we draw our unit circle, it's a bit of a weird looking quadrant. It's something like these. Oops. So here, 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 and here. Okay. But that's when the magnitude, so the magnitude equals square root 3 over 2. And when is it positive? Well, we can pretty clearly see, so sine theta is, sine 60 is this, 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 and this. Alright? So when is this a positive? Well, it's a positive when we're up here. And it's a negative when we're down here. Okay, so we're looking for the answers that will work will be 60 and 180 minus 60. So 60 and 120 are the answers that will work. But those are the answers that will work in 360 degrees, like the first 360 degrees of the unit circle. And we also know that for all n natural numbers, sine theta equals sine theta plus 360n. So for example, sine of 0 is sine of 0 plus 360, so just sine of 360. Because it's the same angle. If you go, let's say if we're at 60, and we go around another 360 degrees, then we end up back here. So sine of 60 plus 360 is also a solution. And we see that this angle is still below 1080. Right, so we've got, let's add 60 plus 360, which is just 420. Now we add 360 to 120, sine 120 plus 360. And this equals 480. So this will work as well, because it's less than 1080. Okay, and then again, add another 360 to 420. So sine 60 plus 2 by 360, 60 plus 720. So if we go around in 2 loops, that will also work, and that will give us 780. And then if we add 120 plus 2 by 360 plus 720, that will also work. And that gives us 840. And then sine 60 plus 3 by 360 plus 1080, that will also work, but the angle is too large. It's now bigger than 1080. So the answers here that will work are 60, 120, 420, 480, 780, and 840. Sine of all these will all give us square root 3 over 2. But this is for theta. So sine, let's just go to the next line. So sine of theta equals square root 3 over 2 for these values. And we know that theta equals 3x. So theta, let's just write it like this. So 3x equals theta equals 60, 120, 420, 480, 780, and 840. All right, so now if we solve for x, so x equals, divide by 3, we get 20, 40, 140, 160, 260, and 280. So sine 3x for all these values will work. These are all the solutions below x equals 360. So this is our answer.